Welcome to this demo of Aster Developer Express. Developer Express is Aster's environment for making it easy to create, test, and deploy SQL-MapReduce functions. I'll be stepping through a simple example today, and that is writing a cube-root SQL-MapReduce function. I already have an n-cluster set up, and I have an input table called toRoot, which is a number of values of which I want to take the cube root. But I'll be creating a SQL-MapReduce function to do this, and I'll step you through this process. So the first step in doing this is creating a new Aster Developer Express project. A project is a container for a number of SQL-MapReduce functions. So create a simple project called demo. And the other aspect of this new project, other than giving the project a name, is associating it with an n-cluster. And so in this case, I already have a test cluster configured, which I've pre-configured to be my local test cluster. This is an actual n cluster, and I can validate that this cluster is currently active, so everything is good to go. So I've associated this project with my test cluster. So I press finish, and now I have a new project. You'll notice that all the necessary n-cluster SQL-MapReduce API jars are automatically imported into this project, so I'm good to go. So once I have a project, the next step is to create a new SQL-MapReduce function. So I again start up a wizard, and in this case I'll create a new function. And the wizard will ask me a number of questions about what kind of function I want to create. So in this case, I'm just going to be creating a simple cube-root function. I want it to be a row function, which is like a map function. And that's all I fill out in this first screen. And so now there'll be a number of questions about this function that I'll be asked, so that the wizard can create an appropriate template as a starting point for my SQL-MapReduce function. So the first question is, what kind of columns should the function accept? Because we'll be operating on that toRoot table, we really only want the function to accept a single column as input, something of type bigint, because that's what the toRoot output, the toRoot table has. So I configure that, so I only wanted to accept input of a single column of type bigint. If a user tries to invoke this function on a different input, they'll get an error. So that's step one. The next step is specifying the mapping between input and output. And there's a number of possibilities here. The SQL-MapReduce function can just pass through its input column so the types match exactly. It can pass through all the input columns and add some additional columns, or, as in this case, we can say it outputs exactly something. In this case, we want it to output a column of type of name root, and it'll be of type numeric, because it's going to be potentially a floating point value. So that's that step. And finally, we can specify what argument clauses the SQL-MapReduce function accepts. Argument clauses are like SQL-MapReduce parameters, basically. But in this case, there's no parameters we're interested in, so we'll just leave this part blank. So we finish, and you'll notice that the Developer Express auto-generates the template code for our function. The constructor, which specifies the mapping between input columns and output columns, is automatically constructed for us. And there's a boilerplate operate on some rows filled in here, which is where the actual meat happens, where the actual processing on a row-by-row basis of the SQL-MapReduce function happens. So you'll notice that right now, this isn't implemented because this is the part we need to fill in. So we have a template function now. So the first thing we want to do is we'll want to be able to test this function locally. So the next step we do is we go and we create what's called a new test runner configuration file. So this is going to enable us to drive or to test a SQL-MapReduce function locally. And so again, there'll be a wizard here that'll step us through the creation of one of these files. And so we want to create a configuration file for the cube-root function, and there'll be no argument clauses here because we don't want to pass the function any arguments. The first step will be to define the input to the function, and so we'll just want to have a dummy comma-separated value file, and again, it has a schema of a column name value of type bigint, because that's what matches the database. And cubroot.in is a perfectly valid name, so we'll just keep it at that. And then, again, we want the output to just only go to the console. We just want the output to be printed, because all this configuration file is going to do is going to specify, it's going to let us test the function locally before we actually deploy it into ncluster. And so the wizard goes through and it creates this input file, this test file. And you'll notice that this is just a JSON file, so although the wizards created it, and this will be good to go out of the box, you can go and edit this file as needed. So it's not some opaque format, it's completely user editable, but the wizard does all the heavy lifting for you if you're just getting started. And so, we've created this, the wizards also created this cuberoot.inf file, which will be the test input to our function. And so we'll open this up and just put in some dummy data that we want to initially test our function on. So there we go. We'll save that. We'll close that for now. So the first thing we want to do is we want to run our function, just the default template that was created. So we specify this test file. We say run as on ncluster, and the first thing we get is this error that operate on some rows needs to be implemented. So remember I mentioned that the function hasn't been written for us yet. So we have to go back and actually fill in this part of the SQL-MapReduce function. So this is where the meat happens, where the business logic is hooked into the SQL-MapReduce function. So in this case, we'll just be doing something simple where we'll extract the input, the value column from the input iterator. So we'll call get long at 0. So that gives us the value of the 0th column, which will just be that big int. Then we'll want to compute the root. So we'll call math.pow, pass it the value, and take it to the 1/3 power. So we're taking the cube root of each input value. And then we want to emit that. We want to emit the cube root. So we take in one row, take the cube root of the one column, then output another column, output the result back into ncluster. And so we'll say output emitter dot add double. We want to output this root, and then we'll say output emitter dot emit row. And so what this will do is emit the result back into ncluster. And it looks like there's an error here, so I'll fix it. And there's another error. No, the error is that I had a mismatch in type, so got to make that along. So now the core of the function is written. And again, this is a very simple example, but the kind of code you could call here can be arbitrarily complex. In fact, you can package your own libraries along with the SQL-MapReduce function and call whatever pre-existing business logic you already have implemented. So we've run that, and so now we can again press run, and there we go. We've run the SQL-MapReduce function on the cuberoot.in test file, and we get the results here. And so we get the expected results because we took the cube root of 1,000, of 27, and of 1. So the function seems like it's reasonable to deploy into ncluster. And note that because we're running this completely locally, we can also debug. So we can set a breakpoint on one of these lines, and we can debug cuberoot.test, and this brings up the full Eclipse debugger. So we can step through the code as it's being run to figure out exactly what's happening to the function as it's being executed. So now that we've written the function and we've tested it locally and we have a sense that it probably works pretty well, the next step is to actually deploy this function and run it on ncluster. And so the way that SQL-MapReduce functions are invoked are from SQL. And so the next step will be to create a new SQL file that will invoke this SQL-MapReduce function. So we'll call the SQL wizard, we'll create a cuberoot.sql file. It will be created, and here's a sample SQL-MapReduce query. So we'll edit this to match our function, which is called cuberoot. And so write cuberoot, and the input table will be toRoot, because that's what I had in the database. And now I want to run this function. And so I run this on the target ncluster. What this will do is it'll build the SQL-MapReduce function, it'll install it into the cluster, and then run this SQL, which will actually invoke the SQL-MapReduce function on the appropriate input data. And you'll note it uploaded cuberoot.zip, which is the packaged SQL-MapReduce function, but it threw an error because cube_root is not the right name of the function. There's no underscore there. So I update my SQL file, save it, press run again. It re-uploads the SQL-MR file, the SQL-MR function, and something's not going right. So I want to run another target N cluster. It runs again. Let me find my console. Okay, it's hiding. So again, the kuberoot.zip file was successfully uploaded, and then it ran this function on the actual data inside the cluster. And so now I get the result I expect from the four rows that were actually inside the cluster. So what I've done is I've built the function, deployed it in N cluster, and then finally run it over real data in the database. And moreover, I have this link here that I can follow to look at the actual logs, the SQL-MR function output while it was running inside the cluster. So this is very useful for debugging actual SQL-MR functions once they're running in the cluster with all the data. And so you'll note that I can switch back to my view of N cluster, and I can look at what files are installed here, and there's kuberoot.zip. There's the function corresponding, the file corresponding to the function that I just wrote, tested locally in N cluster, and then deployed into an actual N cluster for running over large data sets. I hope you enjoyed this demo of Aster Developer Express.